Welcome, algebra class, to another edition of Mr. Chow Time. This is our 6th episode. Maybe more, but this is lesson 6, relations. Let's start off with a bunch of vocabulary words. Hopefully this is just review for you, but if not, then here we go. Coordinate plane. The coordinate plane is an x and a y axis that is used for us to determine locations on the coordinate plane. It has an x-axis, which is this axis here, and the y-axis, which is this axis here. The y-axis is vertical, the x-axis is horizontal. Where the two axes meet is called the origin. The origin's ordered pair is 0, 0, which is the next vocabulary word, ordered pair. An ordered pair is simply the x and y coordinate of a point on the coordinate plane. So this coordinate here would be 4 on the x-axis and negative 4 on the y-axis, which gives you the ordered pair. So for this particular point, it would be 4, negative 4. Okie dokie. The domain and the range are the x and the y values of any relation. And so what I mean by that, that reminds me, there's one more vocabulary word that I've forgotten about. It's this one, relation. And relation is just the set of ordered pairs in some sort of a relationship. Sometimes it's an equation, sometimes it's a function, but we're getting a little bit ahead of ourselves with that. And the last one here is the mapping. Mapping is an illustration of how the domain is paired with a member of the range. And we'll look at that on the next slide here. So here we have some ordered pairs. Ordered pairs. These three are ordered pairs. If we make a table with the ordered pairs, you can see them like this. If we were going to take these ordered pairs and put them on this coordinate plane, they would go at 1, 2, this one right here, and then negative 2, 4 would be right here, and then 0, negative 3, 0 on the x-axis, negative 3 on the y-axis. So those are those three coordinate planes. If we were going to map out these domains and ranges, 1 is mapped to 2, negative 2 is mapped to 4, and 0 is mapped to negative 3. So you see these domain ranges are the x values, and the range values are right here, and they're the y. So that's the coordinate plane, which is the axes put together so that we can determine locations. We have the x and the y axis. We have the origin. We have ordered pairs. We have the x coordinates, which are the numbers on the x axis, the y coordinate, which are the numbers on the y axis. So this is the x coordinate, this is the y coordinate, and then the domain, which is all the x coordinates or the x values in a relationship, and then the y, which is the range. Okay. Let's look at another example here. Let's say we wanted to express this set of points here as a table, a graph, and with mapping. So if we wanted to express it as a table, we would just put the x values here and the y values here. which would just mean we would take the x values and put them over here, and the y values and put them over here. If we wanted to express this as a graph, this first one is 1, 2, 1, 2. And there it is. The second one, -3, 1, 2, 3, 5, 1, 2, 3, 4, 5, right there. 3, -1, 1, 2, 3, -1, and the -1, -3, -1, -3. And then we are going to map it. So our domain figures 2, range 2, they're mapped right across. -3, 5, mapped straight across. 3, -1, mapped straight across. -1, -3, mapped straight across. And then if we're going to list domains, it would be 2, -3, 3, -1, and then the range values would be 2, 5, -1, -3. Now they might not always just go straight across like this, but we'll talk about that later. For now, we'll just do that. Okay. So you may have heard these expressions, independent variable and dependent variable. So in a relation, usually one of the values is going to depend on the other one. The dependent variable depends on the independent variable. The independent variable does not depend on the dependent variable. These independent variable values, they determine the output of the relation. And remember, you can think of a relation as a rule. So y equals 2x plus 1. This is the rule, right? This is what we're going to do to get the y. Each time we're going to put something into here and we're going to get this. So the domain values determine the output. So this is going to determine this one. This one, y, depends on x. We need to know x before we can know what y is going to be. So let's look at an example. A dance committee is selling tickets to the fall ball. The more tickets that they sell, the greater the amount of money they can spend for decorations. So before this ball, which is a dance, this is a dance, which is an event at a school, before they can decorate the place, they need to first sell tickets. The more tickets they sell, the more they can spend on decorations. So do the amount of tickets they sell depend on the decorations, or do the decorations, the amount that they spend on decorations, depend on the tickets? Well, the amount that they spend on the on the decorations is dependent on how many tickets they sell. Does that make sense? So the money spent on decorations is the dependent variable because it depends on the number of tickets sold. Let's look at the next one. Movies. Generally, the average price of going to the movies has steadily increased over time. So we're looking at average price of tickets and time. Time is always the independent variable because time never depends on anything else. Everything else depends on time. This is going to be true almost in every instance. When you're looking at a situation, time is almost always going to be the independent variable because it's unaffected by anything else. Time is always going to march on. Okay. Let's look at some graphs that are unquantified. They don't have quantities, which means they don't have numbers. This is also called qualitative. Qualitative. A qualitative graph has no numbers, just descriptions. These graphs represent a relation that you can interpret. and analyze. So for example, here's a graph that describes a child's height from the ground on a swing. So at the beginning of time, when the child sits on the swing, they start swinging, and with every swing, there is a bottom, right? Because there's a minimum height that the swing is going to reach in every swing back and forth. But every time it swings back and forth, the child gets a little bit higher, a little bit further up off the ground. And that's what we can interpret. We didn't actually see this happen, but we can interpret that because of the graph. We can tell that maybe the child is picking up speed, or it's definitely getting higher and higher. Let's take a look at a couple of other examples. I know these are blurry, but we're just going to deal with it. Describe what's happening in each graph. So here we have someone driving to school. When you first start driving, the speed is relatively high. And then there's a period where we stop. And then we start going again. And this time it's a little bit slower, and then we stop again. Probably maybe for another traffic light. And then we pick up speed again. In both of these legs of the trip, we're going slower than the initial part. Here's another graph, change in income. Over time, we get paid more and more. There is a period where we get a faster increase in pay before it steadies off again, and then there's a short period of time where we make the same amount of money, and then we get paid more and more again. And so that's it. Hope you enjoyed this lesson. Goodbye.